How's it going, ladies and gentlemen? Mr. Johnny here. Uh, Talking about reactions and equations, specifically the conservation of mass and balancing equations. All right, so easy question, starting off with easy stuff. If I created 100 pounds of french fries, how many pounds of potatoes did I start with? Well, let's think about that. If I got 100 pounds of fries, where did that 100 pounds come from? It came from 100 pounds of potatoes, right? Probably not blowing too many minds just yet. If I made a 5 pound omelet, what an omelet that would be. If I made a 5 pound omelet, how many pounds of ingredients did I start with? You know, whether it was cheese, sausage, bacon, ham. I guess you could have some vegetables in there too, maybe some peppers or something. If the omelet weighed 5 pounds, how much ingredients did I start with? 5 pounds, right? You can't make a 5 pound omelet with 4 pounds of ingredients. It's not possible. All right, so that is just kind of like an introduction into the law of conservation of matter and missing mass in equation. So, law of conservation of matter says that matter cannot be created or destroyed. You can't make stuff from nothing, and you can't get nothing from something. All right, typo. Oops. Cannot be created or destroyed in ordinary chemical reactions. In other words, the total grams present in the ingredients, so the grams in the ingredients has to be equal to the stuff that's made, right? It has to be present in the stuff that's made. So in chemistry, the ingredients is what we call the reactants. They're the stuff that are going to do the reacting. They are the reactants, and they're on the left side of the arrow. All right, the products are produced, right? They're on the right side of the arrow. They're things that are being made. So reactants on the left, products on the right. So if we're looking at this example, H2 and Cl2 are reactants because they're on the left side, and HCl is a product on the right side. All right, so it also says that the type and number of each element present in the reactants is also present in the products. The sum of the mass of the reactants must equal the sum of the mass of the products. So what that's pretty much saying is if I started with 6 grams of H2 and 213 grams of Cl2, well then I better end up with 219 grams of HCl. Notice how we have a total of 219 grams on the left and a total of 219 grams on the right. They have to equal each other because that arrow is like an equal sign. All right, so here's a little practice. It says first label the reactants and the products in the equation. So we got C plus O2 giving us CO2. All right, well, which stuff is the reactants? Which stuff is the product? Well, remember the reactants are on the left and the products are on the right. All right, follow-up question. It says what will the mass of CO2 be produced if 72 grams of carbon reacts with 192 grams of O2? Now, here's what I do. Whenever I get a problem like this, let me erase what I got going on here, is I write right into the equation because it's an equation. Let me write the numbers in. All right, so we have 72 grams of carbon. So I'm going to write it right under there. 72 grams of carbon reacts with 192 grams of O2. And it wants to know how much CO2 will we get. Well, here's your equation. If I start with 72 grams of carbon, 192 grams of oxygen, how much CO2 can I make? Well, I'm just going to add those together, and hopefully I do that right. 264 grams. Right? We start with a total of 264 grams on the left, and it has to end up with 264 grams on the right. So let's take a closer look. Here's an example. We have hydrochloric acid, HCl, reacting with zinc, a metal, to give us zinc chloride and hydrogen gas. So there's an equal amount of, is there an equal amount of each element on each side? Well, that's a good question, isn't it? Would this be considered balanced? The answer to both of those is no. Right? If you take a look, there's one hydrogen on the left, but there's two hydrogens on the right. There's one chlorine on the left, and there's two chlorines on the right. So this isn't balanced, right? So if I were to show you a reaction, using the powers of my animation skills, if it's written just how it is, HCl plus Zn, well, let's see what it can react with. Ready? And whoa, look at that. Uh-oh, wait a minute. But the reaction said we ended up with H2 and ZnCl2. That's not what we got. Is not what we got. Everybody panic, right? Now, calm down and relax and think about it and go, hey, how can I balance these? Well, if I need H2, if I need H2 on the right, I'm going to have to start with 2 hydrogens on the left. So why don't I start with 2 HCl's? I think that'll help me out with the chlorines as well. I need 2 chlorines on the right. I only got 1 on the right. So if I start with 2 of these, now I got 2. Now watch what happens. Whoa, look at that. Perfect. All right, now we got our H2 and we got our zinc chloride over here. All right, so everything's hunky-dory. All right, so this is a balanced equation. We have to start with 2 HCl and 1 zinc to give us H2 and ZnCl2, zinc chloride. So this is balanced because we have 2 hydrogens on the left, 2 hydrogens on the right, 2 chlorines on the left, 2 chlorines on the right, 1 zinc on the left, and 1 zinc on the right. So we're good, right? So this is how I would recommend you guys doing it when you have paper, instead of picturing this stuff in your head. On paper, what you're going to do is you're going to create an inventory. You're going to look at what elements are there in the equation, and you're going to make an inventory for the reactants and for the products. So I just split them up just like that, and then you count. You go, all right, let me see, how many hydrogens do I have on the left side? Well, I got 1. How many do I have on the right? I got 2. How many zincs do I have? On the left, I got 1. And on the right, I got 1 as well. And chlorines, on the left, I got 1. But on the right side, I got 2 because of that 2 right there. So now, how do we go about balancing it? Well, if you look at the zincs are kind of already balanced, so we don't have to mess with anything there. So the first thing you're going to do is find something that isn't balanced. It usually doesn't matter which one you start with. Hey, hydrogen, that's not balanced. I only got 1 there. All right, well, I need 2. And HCl is my molecule. So what do I got to do? All right, well, we can't change the equation. We can't say H2Cl. That's not, we're saying it's something different, and that's not what we're trying to do. But the way you can get more hydrogens is by putting a coefficient in front. All right, so you put a 2 in front of that, and now instead of 1, you have 2 hydrogens, but you've also changed the number of chlorines. You no longer have 1 chlorine, you got 2 chlorines. So now I've fixed my hydrogens, they're balanced. My zincs didn't change, they're still balanced. And hey, look, that change that I made to the chlorine was actually good because I balanced that as well. All right, so let's take a look at another example. We got H2 plus O2 giving me H2O. Oh, sorry, go back. So the first thing you're going to do is create your inventory again. HO on the left side, HO on the right side, and I got 2 and 2 on the left side, right? 2 hydrogens, 2 oxygens, so I put 2. Well, how many hydrogens do I have on the right side? I got 2. And how many oxygens? Just 1. So I'm going to look at oxygens. How can I balance these oxygens, right? I only got 1 over here. Well, I can put a 2 in front of this H2O, and now I have 2 oxygens, but I also changed the hydrogens. I have 2 sets of 2, so I have a total of 4 hydrogens now. So I fixed one, but I messed up another. That's okay. You're going to do that a lot. So now, all right, the oxygens are good for now. Well, how do I fix the hydrogens? I only got 2 on this side, and I got 4 on that side. And I'm counting by 2s because it's H2. Well, I know I can put a 2 in front of the H2 because 2 sets of 2 gives me a total of 4. Now my hydrogens are balanced. So this would be my balanced equation. 2H2 plus, that's 1, O2, gives me 2H2O. All right, so the law of conservation of matter says that matter can neither be created nor destroyed, right? Same type and number has to be present on the left side and on the right side. If you start with 1 hydrogen, you got to end up with 1 hydrogen. You can't disappear, and you can't get more hydrogens out of nowhere. All right, in balanced chemical equations, the number and type of each element on the reactant side must be present on the product side. All right, so formulas in the chemical equations cannot be changed. You can't change it. If it's H2O, it's H2O. You can't say H2O2 because that's a totally different thing. You can't do that. All right, instead, large numbers called coefficients are placed in front of the formulas to make equal the number and types of elements on both sides of the arrow. Balancing is always done in lowest terms. So if you had something where it's like, oh, well, I got 2, 4, 2, and 2 as my coefficients, That's not the lowest. You can simplify that to 1, 2, 1, and 1. I'll show you in a couple of examples. All right, so let's take a look. We got Na plus Cl2 give me NaCl. Well, first step I'm going to have to do is take my inventory. I got Na and Cl. I got 1 on the left and 2 chlorines on the left. Now I always make sure to put my elements in the same order for the inventory. I always put, if I put Na on top over here, I keep Na on top, because then I can just look side to side and see, you know, and compare them. I don't have to look diagonal and go, all right, well, I put Na over here. Well, where is it over here? I don't know. It's just a lot easier. So how many NAs do I got? I got 1 and 1 chlorine. So now you look, what's not balanced? Well, chlorine's not balanced. So how do I make chlorine balanced? Well, remember, you can't change this equation. You can't do that. It's always going to be NaCl. You can't change it to NaCl2. So how do I get 2 chlorines? You got to put a 2 in front as the coefficient. So now I got 2 chlorines. But I also changed my sodiums. Now I got 2 sodiums as well. Right? That 2 in front is for both Na and Cl. All right, well, I fixed the chlorines, but I messed up the sodiums. So how can I fix the sodium? Well, pretty easy. You just put a 2 in front of it. Now I got 2 sodiums. All right, everything's done. The blanks are 1s. All right, we normally don't write them, but it's good practice to put them in there. So we got 2 Na plus 1 Cl2 giving me 2 NaCl. I'm balanced. Right, All right, efficient chemists usually don't write the 1, but it's useful to do so because on a lot of test questions, you'll be asked, what is the sum of the coefficients? They're asking you to add all the coefficients together. Let's take a look. So here's an unbalanced equation. So again, I set up my inventory. I put Al, I got 1 of them. S, I got 1. On the other side, I got 2 Al, and I got 3 sulfurs. All right, so pick one, any one that's not balanced. Aluminum. All right, well, I got 2 on this side, and I only got 1 on this side. So I got to put a 2 in front of that. So I got 2 aluminum now. Didn't change my sulfur at all, which is fine, but I still need to fix it because there's 3 on this side and only 1 on this side. Easy fix. I put a 3 in front, and now I got 3 sulfurs on the left and on the right. This blank, now I'm done, is a 1. Now there will be questions where it's like, what is the sum of the coefficients? And you got to add them all up. We got 2, 3, and 1. So that would equal 6. Now if you forgot to write the 1, you might put 5, but that would be wrong. That's why it's a good habit to get into to always write the 1 when you're done for any of the blanks. All right, a little word about the Brinkelhoffs. Remember, the Brinkelhoffs are things that always come in pair. Br2, I2, N2, Cl2, H2, O2, F2. They won't ever be alone. Right, so for example, decomposition of water, it won't just be H. It won't be 2 H's. It's going to be H2. They got to show up in a pair. Same thing with oxygen. So now you go into balance this. You do the same thing. How many H's, how many O's, how many H's, how many O's? I got 2 H's, 1 O, 2 H's, 1 O. We actually already did this one, but it's good practice. Oh, no, I lied. We got 2 O's. So I go, all right, well, I need 2 O's, so I got to put 2 in front of here. Now I got 2 O's, but I changed my hydrogens, and I got 4 hydrogens now. And I only got 2 over here, so I got to put a 2 in front of this because I'm counting by 2. So now I got 4. Now blank 1, you put 1. So what would the sum of it be? Sum of those would be 5. Now I got C plus H2, give me CH4. All right, inventory, CH, I got 1 carbon, I got 2 hydrogens. I got 1 carbon on the right, but I got 4 hydrogens on the right. So hydrogens are imbalanced. So how do I fix that? Well, I'm counting by 2's. So how do I get to 4? Well, I need 2 of those. So now I got 4 hydrogens and everything's balanced. So those blanks are really 1. So what would the sum of that be? It'd be 4. Because we had 1, 2, and 1. Add those together, you get 4. Little trick with polyatomic ions, if they're present and they just switch partners and they don't break apart, you can treat them as one big thing instead of the individual atoms. And it's probably easier if I just jump to an example to show you. So if you take a look, here we have nitrate, a polyatomic ion on the left side. We have NO3. And if we take a look on the right side, they stuck together. The NO3 stayed as one thing. Well, if that's the case, then we can treat it as one thing. So when I'm going to do my inventory, I go AG, and because NO3 is stuck together, I can treat that as one thing instead of separating it into N and O's, and then MG. And I do the same thing for the other side. AG, NO3. Notice how I'm trying to keep the same level so I could just look across and check to see if they're balanced. And MG. So now I take inventory. 1, 1, and 1. 1, 2, and 1, right? NO3s, there's 2 of them right here. So now I gotta balance it. Well, what's not balanced? NO3. I only got 1 on the left side. I need 2. So I gotta put a 2 in front of this. So now I got 2 NO3, but I also changed my AG. So now there's 2 AGs. Alright. Well, now AG is not balanced. I only got 1 on the right side, but I got 2 on the left side. Where did that other AG go? Well, to fix that, you got to put a 2 in front. So now I got a 2. I got 2 AGs. Now everything's balanced. We got 2 AGs, 2 AGs, 2 NO3s, 2 NO3s, 1 MG, and 1 MG. We're good. So what goes in these blanks? 1. So what would the sum of the coefficients be? 6. 2 plus 1 plus 2 plus 1 is 6. All right. So one more example. So let's take a look. All right. BA. Well, NO3. Let's see if NO3 stuck together. Yep, stayed as NO3, so I can treat it as one thing. So I go NO3. I'm going to count NO3s. I got Na, and I got SO4s. Right? You can check the SO4 stays SO4, so I can treat it as one thing. So let me set up my inventory for my other side in the same order, so I can easily look across to check to see if they're equal. And now let me take inventory. I got 1 BA, 2 NO3s, 2 NAs, and 1 SO4. I got 1 BA, NO3s. Let's look over here. I got 1 NO3, NAs. I got 1 NA, and I got 1 SO4. So pick NA or NO3 to fix first, right? We only got 1 on this side, but we got 2 over there. So how do we fix that? Well, I got to put a 2 in front of the compound that has NA or NO3. So now I have 2 NO3s, but I also changed my NA. So now I got 2 NAs as well. And hey, look at that. Everything's balanced now. I got, where's my pen at? 1 and 1, 2 and 2, 2 and 2, and 1 and 1. So everything's good. All right. I hope you found that helpful. And if you didn't, then yell at me in class and get some help. All right. I'll see you there.